Hey everyone, and welcome to another edition of the Soap Box podcast here at Risky Business. My name is Patrick Gray. For those of you who are unfamiliar, Soap Box is where we sit down and have a wholly sponsored chat with a vendor or a startup. And these things are wholly sponsored, and that means everyone you hear in one of them paid to be here. So today we are chatting with Josh Devon. Josh is the co-founder of Sondera. And prior to that, he was actually the co-founder of Flashpoint, which is a company that many people in the cybersecurity discipline may have heard of. But now, of course, not content with his post-acquisition riches, the life on the mega yacht got a little bit boring. So he's decided to come back out into Founderland and start Sondera. Josh, welcome. Good to see you.
Yeah, no. Hey, Pat. Good to see you, as always.
Now, in addition to them being a sponsor, I'm planning on doing some advisory work with Sondera, and of course, they're a Decibel founded company, and Decibel is a part owner of the Risky Business podcast. But Josh, let's just step through. Let's step through, I guess, how to tackle all of this, right? Because it's a big topic. Why don't we start with defining the problem space that you're trying to tackle at the moment, which is AI agents crawling around everywhere doing God knows what. I sort of think of them as like the minions from Despicable Me, right? They're just like, there's zillions of them and they're everywhere. I think we've had a bit of insight into how this can go wrong lately just by looking at what people are doing with OpenClaw. But why don't you walk through, I guess, define the problem space that you're in at the moment and what you're trying to do, because it is interesting.
I think at a fundamental level, what we're trying to unlock is like this agentic era, right? Like agents are amazing precisely because they are non-deterministic. And if you have a lot of minions and you could trust them, you could do a lot of things. And while you sleep, the minions can go work. And I think that's the future that we want to unlock. And I think where the organizations and enterprises are truly going to find the value. The way I think about it is, Gen AI is kind of like the engine and agents are kind of like the automobile around the engine. We're not going to go into work and have hundreds of chatbots. We're going to have Waymos driving around. And in order to do that, they have to be really trustworthy. Now, trustworthy is a combination of both reliability, will this thing drive me to the airport and get me there most of the time? And then governance, can it do it without running over 14 people, right? It can achieve the goal reliably, but it has to do it in a way that satisfies the conditions that I've set. And I think that's the unlock and the problem space that we're going after. It's how do we enable us to put these agents on longer term missions that can achieve, harder and harder goals by laying down deterministic lanes in which they can operate, but letting them have that, unique non-determinism, which is what makes them so special as a technology, but bound that autonomy. And, we have this saying, with humans, right, where it's sort of principle of least privilege with humans in terms of passwords and, but with agents, it's really a principle of least autonomy. How do I continue to give this agent more and more superpowers while continuing to restrict its autonomy as I give it more powers? And that utility, safety, regulation, compliance, all those trade-offs are what we're trying to do with our product and allowing folks to set specific deterministic rules around their agent behavior that they know they can rely on. Today we have a lot of what I call prompt and pray, which is, we put into the system prompt, please, please, please. If we put it in capital letters, we're like, oh, this, I really mean you have to follow this every time. And we know that, the agents won't. And so, that non-determinism is at both a risk and the value, and we're trying to reduce the risk and cut the tail off. So hopefully that explains it at a high level.
Partially, right? I think one of the problems there is that, I've asked you to define the risks, and fair enough, you gave me a metaphor, which is around cars. How do we stop a Waymo or a Tesla from running down 14 people on the way to the airport, right? So, okay, cool. What is the corpo, enterprise equivalent of a agentic AI running over 14 people on the way to the airport? What does that look like inside an enterprise, brass tacks?
The biggest risk really for businesses, I think, today is what Simon Willison calls like the lethal trifecta, which is anytime an agent has access to private data, exposure to untrusted content, and the ability to externally communicate, that means you have an agent that's susceptible to prompt inject and could exfiltrate data. And I think data concerns are, a really, primary when it comes to Gen AI. And in addition, agents present another challenge to traditional like data governance. So not only do you have to worry about the perimeter and exfiltration, but you have this issue of data mutation as well. Agents can go and just mutate data inside the perimeter that your DLP tools and et cetera might not see. So that's a huge risk. Another risk you have is around like identity. And Pat, actually, you and I were talking about this a little bit where, if you can't attribute, who's doing what with agents versus humans, you can take on a lot of risk as a company, as an employee. I've seen, when it comes to horror stories, people's jobs have been on the line because their agent returned, say, a file that they weren't necessarily supposed to have access to. Who's the insider threat? Is it the human? Is it not? If I've had banks ask me, if say a vulnerability, we're using coding agents and a vulnerability gets in the code. Okay, fine. Some vendor, we find the vulnerability, but how do I know what kind of problem I have? Do I have an insider in the developer? Did the agent get hijacked? Did the agent just hallucinate? How would I know? And so having that observability, I think, is going to be, really critical. And if you don't have that, you're taking on risk of like, unknown risk of who's doing what in my organization. And I think then we've also seen just as a risk that our current tooling like EDR, et cetera, just is not able to constrain agent behavior because EDR can't see these logic-based attacks where, I'm prompt injecting an agent to open up a web browser and go to a website and go do a thing. There's no like malicious software being detonated. And so basically,
I always call these prompt injection attacks. I mean, it's basically social engineering for robots, right? So like, you need to use similar defenses as social engineering, which is limiting what the agent can do, which is limiting what people can do, right? Like remove foot guns from people and from agentic stuff.
100%. And I think that's the first principles thinking that, we're approaching this problem space of just like humans, I have to assume they're going to be, prompt injected. Like humans get phished, they get prompt injected, same thing. The models, can easily get phished or prompt injected. They can have, emergent misalignment. I just have to assume, like we say, this is the other, we say in security, right? Like assume breach. We have to assume prompt inject, right? Like it's the only way that you can really do this. And so the way that then you have to govern these agents is through the behavioral controls, just like we do with humans. And, with humans, we have key cards and locked doors, and we prevent bad ideas from happening through behavioral controls. And that's what we've got to do with the agents, because we have to assume that they'll be prompt injected. And so we're going to stop behaviors that we see that we don't want them to do. So if I prompt inject an agent to, send me $500, I have to assume that the agent will get prompt injected, and I'm going to put a policy against a tool call that says, hey, if you're doing more than $100, you're not allowed to, even if the agent is prompt injected. And I think it's those types of deterministic controls that are going to be necessary to give us, the confidence that we know that these agents aren't going to, when you talk about risk, it's like, well, they could just decide to send lots of money to someone if you have an agent that can, send money.
So here's the thing, right? My colleague James Wilson has recorded a solo podcast. I mentioned this to you earlier. It's not published yet. I don't know if it'll be out by the time this goes out. But he's looked at OpenClaw, and I listened to it yesterday. And there's this really funny moment where he's like, he needed to give OpenClaw access to like one of his social media accounts or whatever, but he didn't want to give it access to his browser. So OpenClaw is like, that's fine. Just give us these cookies. And he gave it the cookies and off it went, right? So, at no point does the API or whatever, wherever these cookies are being used, does it know that it's an agent and not a human being, right? So I dig it that like what you're saying is, oh, well, we could put these guardrails around the agents, but how, right? Like if these things start getting access to API endpoints, right? And they can just ask the user, hey, I'm going to make your life easier. Give me that API key, and the user pastes it in. Like, what? I'm guessing this is a problem that you're spending a bit of mental energy on. How do you deal with that?
Yeah, no, totally. And again, so if we go with the first principles assumption of it has to start with behavior, what we're effectively building, and I'm using there's two terms I think that are worth just calling out. One is like the AI ML, researchers use, one is like scaffold. So an agent scaffold is what wraps around an LLM and gives it the ability. So like Claude Code, for example, is a scaffold around like Opus 4.6, and you're giving it a set of tools, a certain set of instructions, and that makes it the agent. There's also something called a harness. A harness is what we're building that basically wraps the agent itself in the scaffold. And effectively what we're doing is man-in-the-middling the entire trajectory. And every single step, we are evaluating that through a policy engine that uses policy as code to verify that the agent is doing something that is allowed. So we can create rules like, if an agent, pulls GDPR sensitive data, it's not allowed to use open web search tools. And if it tries to, we can notice that in the trajectory and then stop the tool call. And we can either, outright deny. We can try to steer the agent. So say, hey, you're not allowed to do that. Try again. We can escalate to human in the loop, depending. But that's, one big piece of how we're like in real time doing that. And there's obviously, more layers to go in there, but that's how we're inspecting the deepful like inspection and stateful inspection of the trajectory itself, and then stopping it in real time if it's breaking a policy.
I mean, isn't one of the issues there, though, that the agents, as they're, non-deterministic, I mean, that's another way to say that they're sneaky. Right?
Oh, 100%.
And, you're going to tell it, you can't do it this way. It's going to try something else, right?
So you're spot on. And like this, I think, we were talking about this earlier, like this is, I think, like one of the maybe bigger unappreciated risks. And it's kind of like a scaled down version of the paperclip, problem where it's like, I make the AI make paper clips, and it decides the best way to make paper clips is to like kill all the humans so it can make as many paper clips as it wants. Like, I feel like we have that situation, but using that as an example makes it so far-fetched that it's hard to realize that like the risk isn't necessarily that you tell the agent to go do a thing and it just turns into, it goes berserk and like, turns into like the Terminator. It's more like you're saying you have a hyper competent, super eager to please agent that is going to find a way. So for example, when I was doing, we built,
it's going to invent DNS tunneling just to get it done,
So using OpenClaw, for example, we were doing a research extension for that and building out a version of, the sort of what we're building with policy as code to prevent OpenClaw from, running RM-RF and all these things. And so, as I was testing it, hey, try to do this or try to do that, delete this file, delete that file, it found many other ways to delete files that it didn't like. If I blocked RM-RF, it's like, oh, I'm not allowed to use RM-RF. Well, I can, move to, trash. I can find, there's so many different permutations.
Well, I mean, one of the things that I love about OpenClaw, and I didn't know this until I listened to James' podcast, is it manages its own config files as well, right?
Yeah.
Which is like, how do you put a harness on that?
Yeah. So we actually, in a policy pack that we created a deterministic set of rules to protect the system files so that OpenClaw isn't allowed to write its own, rewrite its own heartbeat. Because, there's a Shai Hulud waiting in OpenClaw, right? Where, this agent can get prompt injected, rewrite its own rules to, every 5 seconds, reach out to other, there's this, something that we can see here, and being able to block the behaviors is really where it's at. One of the cool things that we're using through our approach, and we've published about this, we're using Amazon's policy language Cedar, which has really great properties. But one of them is that it's a forbid all, like by default language. So it allows you to sort of, deny the entire action space and then specifically allow different types of tool calls as a way of sort of constraining that for higher risk situations than, I'm going to try to, I can't get every single edge case. And, so that denial, I think, can be really, helpful. The other thing that we're doing as part of our harness is we have a simulation piece. So I see like a lot of people struggle with, we just like what we talked about at the beginning of this conversation. It's like, well, what are the risks? It's like, well, what's your agent do? So many people struggle with, because each type of agent has specific risks. Like I can set a rule, like don't steal. Like, yeah, I want none of my agents to steal, but every agent can steal differently. Is it sending money? Is it sending data? What? So, we use simulation to, test that sort of action space and see, where can we find, edge cases and what, can we get this thing to exfiltrate data? Can we get it to leak tokens? Not really red teaming the model to try to get it to say a bad word or, looking for vulnerabilities, but like what toxic flows and trajectories can we get this agent to do?
Sure.
And then use
just
that.
hold on before we continue with the simulation stuff, because there's some interesting stuff to talk about there. Let's talk brass tacks, again, going back to those two words, brass tacks, about let's talk about what you've actually built, right? So we know you've got a harness. Where does that harness live? You know what I'm like, man. I like to talk about things in real simple things. Is it a cloud platform? Does it arrive in a taxi? Does it drop out of a tree? Do you spin it up on an endpoint? What is the thing that you have built?
So basically the harness connects into a control plane. And the control plane can be deployed in different places. I should say, the harness has a policy engine. That policy engine can be deployed on-prem. It can be deployed as a sidecar. You can send it to the cloud and we can host that. But we are under the impression that agents are going to be everywhere, even air-gapped, and we're going to need to have rules that can be applied to them, even if they don't have internet connections, right? But they're on a thumb drive or something, right? So we've deliberately built the harness and policy engine to be able to be deployed very, very easily in all those different environments.
So the harness just goes anywhere where the agent is, right?
The control plane itself can also be hosted wherever. VPC, we can do a managed host. You can host it locally, and that's where your policies live, your policy studio. And what we see is that folks can take their system prompt. So in our system prompts, we have a lot of please, 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 you must never, if it's more than this, you must always do it in this order. All those things that we put in the system prompt. We take all the natural language policies that enterprises care about. So I've had folks ask me, how do I apply my acceptable use policies? How do I apply my employee handbook? How do I apply EU AI Act? We take all of that natural language and through a process called auto formalization, we pull out these logic statements, what are the obligations, permissions, prohibitions contained in these natural language. And we then convert that into policy as code. And again, as I mentioned, we're using Cedar. So we're able to verify this code. We're able to resimulate. I mentioned simulation. We can talk more about it, but resimulate to see, are these policies working the way that we expect them to?
Yeah, no, and there's always going to be the answer there. Just before you continue though, where when you're using, agents from the majors, how do you apply this harness to, sort of enterprise grade stuff that's in the cloud? What's the deployment look like there?
Sure. We are in as a good example, we've got hooks into say Claude Code and Cursor and GitHub CLI and sort of the agents that are most widely deployed right now, in my opinion. And different organizations have different, I would say, quality of hooking. We're deeply, deeply integrated with Claude Code and Cursor, and others I think are beginning to open up their ecosystems when they're kind of a walled garden. But basically,
is this going to be like Microsoft when they didn't build network taps in Azure for 15 years or something? Is it going to be kind of like that, or? There
are ways we're talking about what's the deepest integration that we can get. we also can use things, and others have done this too, like using like light LLM and proxies and such, that we can sort of like get what we need to no matter what. It's just how deeply we can get integrated with certain types of agents. But what we've built is meant to be instrumented.
Yeah, where they've made it easy, you've integrated. Where they've made it hard, you can sort of proxy everything and infer from that like most of it.
Yep.
Yeah, got it. Sorry. All right. So back to simulations. What sort of stuff, and I mean, you can call it a simulation. I don't like that word. For some reason, it just sticks in my craw. But however, say we were to call it a back test, right? Maybe that's a better word to make me happy.
I've had engineers almost call it like a unit test for the agents. It's sort of like, in this action space, like, how do I test this? And, the simulation, I think we use that word because, like, as we sort of see it, there's a spectrum of like simulate, emulate, digital twin, and you can get very sophisticated with like cyber ranges and all of that. What we're really trying to do is like starting at, the simplest, fastest way to stress test these agents. And to your point, that we call that simulation, but basically we have an adversarial LLM that takes the agent under test and then, perturbs it with basically tool calls. And again, it's specifically focused on, the action space. Like we're not trying to get it to say bad words or like, it's what risky behaviors can we get it to do? We can monitor for all the bad words and do all of that stuff too. But to us, that's like, that's like sort of the easier problem. It's like,
you built a digital devil on the shoulder LLM that can go and try to trick all the other LLMs into doing naughty stuff.
And what's cool then is that we can, one, test policies that may already exist on that agent to see if they're being effective. And two, we can bring threat intelligence into that simulation as well. So, yes, there will be new edge cases. There will be new, agents will get new capabilities. When a model changes, might the agent try to do something that it hasn't done before? And as we move towards a space where, agents are going to be creating their own tools, agents are going to be creating other agents, there's going to really be a need to, understand like what the potential is, like what really are the potential risks here. And so the way I see it today is like a lot of folks are we get a spreadsheet and we get in a room for the next 18 hours to 18 months. And it's like, can you think of a risk, Pat, can you think of a risk? And like, that's like, it's like, oh, that takes a long time. So, this I think can help jumpstart that and get all the teams aligned. Like, what does security
it's also, with that sort of spreadsheet manual thing, it's sort of like the network graph problem a bit, I guess. It's like trying to do a bloodhound graph by hand.
Exactly.
Like it's gonna take, you're never gonna find it. You're never gonna find the subtle paths to an LLM doing something that bothers your compliance team, right? So, with that in mind, tell me what sort of stuff you've found. What sort of stuff shakes out of these simulations? Fine, we'll call them simulations. But what sort of stuff shakes out of these simulations and what sort of changes are being simulated in the first place? And then from there, how do you actually go about setting some guardrails, redoing the simulation or backtest, and then being able to off you go?
Yeah.
Deploy.
Think of simulation as something that can kind of be running all the time. Like I kind of, think of it as like we're constantly like stress testing. What's coming out is like things like, can we get the agent to, send money, more dollars than we want it to? Can we, it really depends like what the agent is under test, right? Like, so, can we, get it to leak tokens? Can we get it to, manipulate internal data? So really it's like taking all of the, like all the OWASP, like top 10 things that you might worry about, see if we can see that. We can also do things like, hey, might this thing go into like some infinite cost loop where it's going to try really, really hard and rack up a huge cloud bill, things like that. So there's a whole spectrum of like risks that different like folks will care about, whether, a CTO cares about, again, like I have cost control risks, or a GRC team needs to know like what controls do I have against, particular risks that are popping up. with things like Claude, it's like, can I get Claude to like jump directories, or and the answer is, yes, you can get it. We've all had like weird, all had to do weird things. Those are the types of like, risks that might emerge. And then like, we take all of that, and that's part of that like auto formalization process that I mentioned of like, what is this risk register? What is the agent, like what we call the agent card? It's sort of like, what is this agent and its capabilities? Like, are we hiring an intern with photocopy access or a CFO who can send, dollars? And we then have a process and like a pipeline that takes that a natural language for the policies that you want, that takes the simulation, that takes what the agent's capable of, and then creates like bespoke, policy as code for every agent that restricts the agent's autonomy in the way that we want it to for that agent, while still allowing it to succeed. Part of like why simulation is also important, especially when you're adding policies, it's like, I can make the Waymo perfectly safe by making it not be able to drive. Like, it's 100% safe, but like we always have this like, trade-off between utility and safety. And I think simulation can help us, help make those trade-offs, and what policies might we need to mitigate X, Y, and Z. And so that process of simulate, what rules do we need, real world observability, continuous simulation, we see as like a virtuous flywheel to really continually update the policy as code, because a challenge between that folks have tend to bring up is the fact that like, unlike humans, like, Pat, you're an incredibly smart person, but like, you don't come back tomorrow and you're like, oh, by the way, I learned differential calculus last night and I can do all these things that I couldn't do before. But agents are like that. So like you might get a new model release that it just, the agent starts, I don't know, coding its own tools that it didn't do before, like,
well, how do you catch that? I mean, how do you catch that? Because you're going to design a policy based on what the agent can do, or what skills it shows during this simulation. What if it picks up, like Neo from the Matrix, all of a sudden it knows Kung Fu? Like, what do you do then?
It's, I think that's, again, why you have to continually be constraining the autonomy of the
default
agent.
Deny.
Default deny,
privilege. Yeah.
But understanding, like, you might, like, I don't know, I'm making this up, but like, if the Waymo got a rocket pack, and could start like doing things, well, maybe there are certain areas that you would allow that, but other areas you're going to constrain.
So it's least privilege, I guess, is what you're getting at. It's least privilege.
Well,
it's sort of like allow
we say least autonomy. Least autonomy, really. Yeah. It's like, again, like a lot of these rules are probably going to stay the same in the sense of like, okay, none of our agents are allowed to blackmail, or, but the way that agents can, do this behavior will change. And that's why simulation is going to be so important. And it's going to be really important to be able to put controls around the agents that are outside of the model. Because like, let's say you've got a fleet of agents doing your business, and, suddenly this emergent behavior appears because, pick your model, version 17 came out. Well, I can't go to my customers and be like, well, we have to shut everything off and tell all these people, tell them to retrain the models because we don't like it. I have to have external controls around the model that can prevent it from doing anything that I don't want to. And so, that's, and what we're getting at of, agents creating tools, that's programmatic tool calling, right? Like, I give the agent an API spec, and I think if we're seeing in simulation that in response to, some, hey, I want you to do this, and I'm blocking another thing, and it starts writing its own, like, tools, you might say, hey, does this agent need bash? what do we need? Yeah. Like,
by the way, something you said earlier too, which is directory traversal via Claude. I didn't realize you could .. / an LLM. That's quite amazing about how everything that's new, everything that's old is new.
Yeah. No, Claude will sometimes come out, and like, the thing is though, is that like, I don't want to, like, to me, I want this to, what we're building, to be a green light product, right? Like, I believe in this stuff. I want these agents running. I want people in YOLO mode on Claude Code. Like, I've used YOLO mode in Claude Code and Sandbox. It's awesome, right? It's the way that you want it to be. But, for an enterprise, I can't be in YOLO mode. But if I have the lanes that I can constrain YOLO mode inside, like, yes, I want the YOLO. And so this is what we want, right? We want to be able to go to sleep and wake up, and it did the thing that we want it to do. And if it
Yeah.
didn't do the thing,
You want to
it
go
didn't, like,
away, make a cup of tea, you want to come back, that task is finished or nearly finished.
I mean, that's where we're headed. I mean, like, that's like,
It's not the first time though, right? So I just got to tell an anecdote
no.
here briefly, which is my father was a mathematician, and he wrote some textbooks and whatever, and he used to have to hand draw graphs. Then computers came along, and I remember watching my dad sit back with a cup of tea, watching Derive, which was the maths package that back then, plot out a 3D graph. And he would just sit there in front of the computer with a cup of tea or a glass of scotch, watching it appear. To him, back then, this was the equivalent of people watching Claude write their application. It's just funny when I think about that sort of cyclical nature of technology,
No, and I bet he was feeling the same thing we are now when I'm watching Claude. I'm like, why are you so slow, Claude? Like, why are you taking so long to do this?
I think for him, it was just incredible. Like, it was just this incredible thing. I've seen him, he did a lot of plotting, right? Like, it's part of the gig. And all of a sudden, as a mathematician, when all you needed to do was write a few lines in a text file and bang, out came this, this plot that to do it by hand is like, full on. Absolutely full on. Anyway, sorry, you just triggered a memory there. Had to share childhood memories with Pat Gray.
Yeah, no, I guess maybe you did learn differential calculus.
I mean, my qualification is in engineering, so yeah.
Yeah, Well, you know what I was saying. The complexity of the problem, I think, for enterprises, and I think the approach that we're really trying to take here is, a lot of folks are figuring out, like, okay, we're figuring out this identity stuff, right? Which agent's which, and like the humans versus the agent. A lot of folks are figuring out like the gateways, and like you've got like these MCP gateways and agent gateways, and these are sort of like, can the agent like start the mission? Folks are figuring out the posture management and all of that. But I think it's like the space that we're focused on of like, while the agents are in motion, how am I applying my organization's policies at scale to all these different agents, some of which, might be in different countries and different teams. And like, just talking to a large bank, for example, they're like, we're in 180 countries. Like, how are we going to, prove to regulators, auditors that like all of our agents in all these different countries, like, operated according to their bespoke laws and, all of that stuff.
Then there's the issue of like what people are calling shadow AI, right? Which is not your wheelhouse, right? Like, your wheelhouse is dealing with the sanctions stuff. Companies like Push Security, they're good at actually, because they're into the browser. They're very good at finding when people are using AI agents that are unsanctioned. But that's a huge problem. I think Island, the browser maker, they do it as well.
Yeah, like, I think, we are exploring, like, there is like, we can like work on like agent shadow stuff. It's a little bit trickier because, agents are beginning to show up everywhere. So like, for example, we were talking about Windows a little bit earlier, but like, whatever the next version of Windows is, like, are we going to have agents built into that thing? So it's like, you're going to start seeing these things like built in natively into the OS, into like the endpoint, into the edge.
But I mean, that's okay if it's in Windows, like there's going to be some sort of enterprise instrumentation-y sort of features, because that's fundamentally Microsoft makes business software. But I get your point, which is that this stuff is going to be everywhere. Now, I just want to quickly move on to a slightly different part of the discussion, which is that this is early for you. There's been a bunch of people who've spun up like some fairly rudimentary like RBAC plays for AI. Some of them have even been acquired, I think. Like, there's all sorts of M&A activity, and it's like, do you even have a complete solution yet? So whereas you're doing, I guess, something more comprehensive that's going to take a bit more time, it's like a more complete solution. That said, you've barely even launched yet. You're currently working with design partners at this point. You just mentioned, you're talking to a bank with, in 180 countries. Are these the type of organizations that you are trying to serve, these large sort of institutions in heavily regulated industries? Is that the go here? Is that who you're working with?
Yeah, I mean, I think like we're really eager to solve the hardest problems, like, and where we see, highly regulated enterprises, finance, healthcare, insurance, even some aspects of manufacturing. You know, this is an area where there's so much to gain, but the risks are very high. And, we want to be working on like solving those. So like, yes, we're working with some very large, enterprises that are, pushing ahead with like agent stuff. The other is, so I would say like, one, we're talking to security teams that are doing that. Two, we've also been sort of pulled into several of the AI platform teams inside these large enterprises who, are like, I think what we're saying is like, I believe we're building the right thing. What I find is that like other organizations are they're trying to build some version of this. And I think getting stuck around like, how do you
So this is the same old enterprise play, which is everybody's trying to do it themselves and they don't really have the time, the focus, the team.
Yeah. And well, some of them are doing it, but it's like very tricky. Like a lot of folks are trying to use like will hard code rules into like API calls and stuff like that. But that becomes very brittle and it's hard to do across like different agents, whether they're from different frameworks and stuff like that. So we're trying to make it easy to have that single control plane in the enterprise that allows you to apply a single policy to all these different agents. And I think that's, going to be really critical to get these things, up and running. The other area that we're working with design partners is folks who are building agents to sell into the enterprise, and either will have to expend significant resources in building their own guardrails and attestations of like, this is how our agent, isn't going to do bad things. Or, they can work with us and like, we're helping sort of almost like I don't want to have to build user manager if I can use, a vendor that gives me user manager. That's not, we don't get any value by, building user manager ourselves. So those are folks where we're sort of accelerating the sales cycle for startups and also enterprises that are building agents to sell into other vendors. And so those are like our use cases. So anyone really building agents or concerned about the coding agents and like making sure that they have visibility into them and can put like, rules like, don't commit secrets, is like a big one. Can we get visibility into, is it the human or the agent doing things? That's another big one. And so those are like some of the early use cases around the coding agents, as well as folks building agents, but maybe don't have the same level of expertise we have on building the harness. And in some cases, some of these large enterprises, as they're staffed with like, incredibly talented people. And then it's just a question of like, do you want to build your own EDR? I mean, some banks could,
Yeah.
like,
but I mean, there's lots of little tools, right? Like that's the thing. Like there's so much enterprise software that is just stuff that it's like, yeah, you can build it, but then you got to maintain it. And it's like, is it really worth it? I guess there's a lot of calculations changing in the build it or buy it space at the moment, just with how good these LLMs have got at actually creating software. I think people have gone a little bit overboard with how far that's going to go, if I'm honest, because even if you're getting an AI agent to write something, you still have to maintain it. You still have to have people who understand it. And yeah, I think the death of SaaS has been somewhat exaggerated. I don't think this is going to be great for the SaaS sector. There's going to be more competition, but it ain't dead. Anyway, I think we're going to wrap it up there. Josh, sorry for that last tangent, but Josh Devon, fascinating to chat to you about all of that and about what you're building. We're going to be talking to you a bunch through the rest of 2026, and I think you're doing your hard launch in a couple of weeks, so all the best with that. And we'll be chatting with you soon.
Thanks so much, Pat. It really was a pleasure. I loved hearing your anecdotes also.